Ready? 3, 2, 1, action.
Welcome to MRU E-Learning, powered by Malla Reddy University. Myself, Dr. Kanavena Ashok, Assistant Represents School of Engineering, Data Science Department. Today, I will discuss about classification of data types. What is mean by data? For example, data means collection of information is called data. Any information is called data. For example, college data, student data, faculty data, company data, other data. So, what is structure? Representation of data. Collection of data is called, we are representing the data means we are representing the table like any format. Whatever your convenient, that format you are storing the computer. That is called representation of the data. Nowadays, many people having more data. So, information is called data. What is meant by data structures? Data structure is a systematic way organizing the data in a computer so that it can be used effectively. For example, you are storing the data means whenever you want the data, you are easily access to the data. That is called data structures. Classification of data. Classification of data types means two types. First one is primitive data structures. Second one is non-primitive data structures. Primitive data structures means already predefined data structures is called primitive data structures. Non-primitive data structures means with help of primitive data structures. With help of primitive data structures means derived from the primitive data structures. That is called non-primitive data structures. Primitive data structures are integer, character, float, double. Integer represented as numbers. Okay, next floating represent as float numbers as represent as, for example, factorial numbers. Factorial numbers means 3.4 like that. Next character. Character is the single character like that alphabets A to Z. Next string. String represent as character hi, hello, or data like that. Okay, Boolean variables represent as true or false. Coming to non-primitive data structures. Again, non-primitive data structures are two types. First one is linear data structures. Second one is non-linear data structures. Linear data structures means data organizing the sequential order. Non-linear data structures means data arranging the non-sequential order. The linear data structures are again two types. First one is static. Second one is dynamic. Static data structures are arrays. Dynamic data structures are stack, queue, link or leak. Static means whenever you declare the array, for example, array size is fixed. Dynamic means whenever you want the data, where added the flexibility is possible to dynamic data structures. What is array? Array is the collection of same data types is called array. Non-primitive data structures are derived from the primitive data type. Same or different data types are the primitive data structures. Linear data structures means already I told sequential order. Examples of linear data structures are arrays, stack, queue, linked list. Non-linear data structures means to arranging the data is non-sequential order. Examples of graphs, trees, tables. Graphs, trees, tables. Represent the graph data is represented the graphical representation of the data is called graphs. Coming to dynamic data structures. Dynamic data structures are stack, queue, linked list. What is array? Array is what is meant by array? Array means collection of elements with same data types is called array. Array memory is continuous memory allocation with the same data types. Okay, array is used to multiple values in a single variable. This figure showing, for example, int is the type of array. Array name is array new. Int is a int of array size is 10. Array index starts from 0 to an element. For example, we are declaring here array size is 10. So index starts from 0. So 0 to 9. For example, basic address is whenever you want the address means 1 to 1000 or 104 like that. Okay, this is the memory is continuous memory allocation. For example, we are inserting the elements in the array. We are continuous one by one sequential order only. We are maintaining the arrays. Next, coming to dynamic data types of stack and queue and linked list. What is stack? Stack is the linear data sets which elements are arranging in the sequential order, in which elements are forming LIFO manner. For example, LIFO manner means last in first out, last in first order. For example, we are inserting the array in first element is stored at last position, last inserting element at inserted at first position. Stack is a linear data set which elements is inserting and deleting is the only one element, like stack up the plates and stack up the books, water bottle. Real time examples of stack is stack up plates, stack up books, and water bottle. Water bottle also we are filling the only one end and outing the only one end only. That is called stack. Stack is implemented with two ways, using the arrays and using the linked list. Stack operations is push operation, pop operation, pick operation, is empty, is full. Push operation to insert the element in stack, that is called push operation. Pop operation to delete the element of stack is pop operation. Pick operation to display the top of the element is called pick operation. Is empty, is full. Stack is empty or stack is full. For example, here declare the array size is 5. So index starts from 0, 1, 2, 3, 4. So for example, we are inserting the data in only one end, top end. So I am inserting the first element in 10. Second element is 10. First of all, how to insert the element in stack? First, we are declare the one indicator top equal to -1. For example, whenever top equal to -1, the stack is empty. So if you are inserting the element in stack, so whenever you are inserting the element in stack is top plus 1. So already we are indicating the top equal to -1. Top equal to -1 means stack is empty. So we are inserting the element in stack. So top plus plus. So -1 plus 1 equal to 0. So first we are inserting the element in 0th position. Second element already top is 0 position. Next we are inserting the second element in top plus 1. So already 0 plus 1. So second element is inserting at the first position. This is called how to insert the element in stack. For example, delete the element in top -1. For example, if top equal to size -1, size is already array size is 5. So 5 minus 1 already equal to 4. So that's why fourth index of 4 equal to already element is there. So stack is display the stack is overflow condition. Coming to stack algorithm, already if I told if top equal to size -1, for example, top equal to size -1, stack is full. Else condition false in case read the data items. Whenever you are inserting the data in stack, so top equal to top plus 1. So 0, 1, 2, 3. So array size is 4. So first top equal to -1. -1 means stack is empty. Whenever stack is empty, we are read the item and we are inserting the possibility is there. We are inserting the element in stack. So then read the item are equal to top plus 1. Whenever top equal to top plus 1, so size -1. This condition is false. Whenever means this condition is false, so we are inserting the elements in the stack. So this is the algorithm of push algorithm. If top equal to size -1, whenever top equal to size -1, stack is full. Okay, next condition is false. For example, read the item. We have the data. We have read the data. Then after we are inserting the data in stack. Okay, next coming to pop operation. To delete the pop operation, if top equal to -1, top equal to -1 means, for example, top equal to -1, stack is empty. No need to delete any elements. For example, condition is false. We are read the data. Then after we are inserting the elements in the stack one by one. Stack is disadvantage is only inserting on one end and deleting also one end. That is called push algorithm, pop algorithm. Next, peak algorithm. We are using the peak algorithm only display the top of the element in the stack. That is called this algorithm is only using only top of the element only displayed. Is empty, is full. For example, is empty, the algorithm is if top equal to size minus 1, stack is overflow. Stack is full. Empty if top equal to minus 1. Is empty, is full. This is the algorithms of stack operations of push algorithm, pop algorithm, peek algorithm. Next, coming to dynamic data types of Q also linear data structures, which elements are arranging the sequential order, in which elements are forming the FIFO manner. Stack is LIFO manner, Q is FIFO manner. FIFO manner means first come, first serve. Okay. Next, first in, first out order. Okay. So Q is the linear data structure. Insertion is the rear, deletion is the front end. Here 1 and 2 insertion, 1 and 2 deletion. Stack is only 1 and 2 insertion, 1 and 2 deletion. Q is different. Q linear data structure is element in the rear and deletion in the front end. Examples of Q is ATM centers, railway counter. For example, ATM counter also first come, first serve. First come, first serve. Q is implemented with same using arrays, using linked list. Q operations are NQ operation to insert the element in Q, DQ operation to delete the element in Q, display operation and full Q and empty Q. Coming to linear data structures, next one is linked list. What is linked list? Linked list is also linear data structures which contain collection of elements which are connected together via link. For example, linked list data is stored in node format. For example, node have two parts. First part is data part, second part is address part. Data elements are data elements called nodes. Each node has two parts. First part is link part, second part is data part, another part is link or address part. Data field store actual data and link field contain address. Address means we are stored at the pointer of next node. Address you are stored at a previous node. So node is node divided into two parts. First part is data part, second part is address part. What are the advantages of linked list? Linked list is the dynamic data structure. So array is the static data structure. For example, we are declare the array. Array is fixed size only. Whenever you are declare the array, that time only fixed. That time once you are declare the array you can't change the any memory. For example, linked list means whenever you require the data, that time we are inserted at the fields. So these are the advantages of linked list. Linked list is the dynamic data structures. No need to specify the number of the elements in the advance. For example, array is advance only. Linked list is no advance. Whenever you want that time you are adding the advance. Whenever you want the data, whenever you want the memory, you need to declare that time. Okay, memory allocated only whenever is required. No wastage of memory. For example, we are declare the array. For example, array means, for example, you are declare the array size is 10. For example, you have data is only 5. So that time you are inserting at the 5 elements in that array. So remaining memory is wastage. Here no wastage. Why? For example, linear data such linked list is insert begin, insert end, insert position, deletion, delete begin, delete and delete position. Whenever you don't want the data, that time also you deleting the data. So that's why no wastage of memory. Insertion and deletion operations are easy. Means insertion and deletion operations are easy means whenever you want the insertion of the data, immediately you declare the array and we are inserting the element. Stack and queue implement with using linked list. Already I told you stack and queue implement with arrays and linked list. Disadvantage only whenever your extra memory space is required, that time we are using the pointer variables. What are the operations of linked list? For example, operations of linked list means creation and insertion, insert begin, insert end, insert position, deletion begin, deletion end, deletion position, and sorting techniques, traversing and display. These are the operations of stack. The operations are, these are the operations of searching the element. One element you are searching, one element you are sorting, one element you are traversing, forward and backward traversing, and display display the elements of the linked list. For example, how to create the node? Create the node means we are using the two types. For example, we are using the structure and we are using the class. For example, here class, for example, node is a class name, hint data, node equal to link. Immediately one node is created here. Okay, this is the data part. This is the link part means next node address part. So whenever you write this code, these two lines of the code, immediately one node is created. Next is insertion, insert begin, insert end, insert position. Whenever you want the data, for example, here one node is there. Next we are inserting the next node, immediately next node also inserted. This is the tempo. For example, this is the rare. This address is 001, this address is 1010. Immediately this address is stored at previous node. So this is called linked list. Types of a linked list means single linked list, double linked list, circle linked list. Single linked list means only forward direction. Double linked list means forward and backward traversing. Circle linked list means nodes are connected with the circular. First node is connected with last node address. That is called circular linked list. What is linked list? What is single linked list? Single linked list is the linear data structure which contains the sequence of element in which every element has a link it to next element in the sequence. Single linked list is the individual element is called node. Every node contains two fields. First one is the data part, the second one is the address part. That is called single linked list. Here this image is showing showing the node. Node is the name of the node is node. So first part is the data part, second part is the address part. Here we are inserting the elements 10, 20, 30. So for example, this address is 001, 010, 100, 001. For example, next node address is stored at previous node. Okay. This is called single linked list. Single linked list means only forward direction is called single linked list. For example, double linked list also traversing backward traversing also. That is called double linked list. Linked list, for example, already single linked list is insert in begin, insert end, insert position. This is the algorithm of how to insert the element in begin. For example, here you are using the structure node. For example, to struct node means node, once we are creating the node. So into data, for example 10 here, okay, node equal to link. So here we are declare the star means star is the pointer available. We are store the node in address point. Okay. For example, here front and rear. For example, here this code, whenever you write this code, immediately these two are declared. So this is the front, this is the rear. For example, next we are insert begin. So first we are elements is not there in the linked list node. So that's why front equal to null, rear equal to null. Next we are insert begin means first we are declare the one node. One node means a temporary node. For example, node star temp equal to new struct node. Immediately one temporary node is declared. So temp data means we are inserting the 10 in the temp data. So 10. Next temp link equal to null. So first we are checking the node is empty or full. First if front equal to null, rear equal to null means so node is empty. Immediately we are inserting the elements in the node. So front equal to temp, rear equal to temp. For example, only one node is there. So that's why that time front and rear is same position. So we are declare only temporary node. So that's why front is here, rear is here. So this condition is we are check. Else the condition is false. So immediately temp. For example, temp link equal to front. Front already elements is there. So front link equal to temp. So front link equal to temp. Immediate I called front link. For example, I called friend means friend equal to 1010. Friend data is 10. Friend link address is link. Friend address is equal to link. Okay, this element. Okay, I called only temp. Temp means this is the 1010. Temp data means is a temp. Address means like this. So that's why we are easily connected with this temp link equal. I call temp link equal to friend means immediately temp link. Where is the temp link? Immediately friend is stored is here. So next yeah, already here temp. So one data is there, friend is there, rare is there. So immediately friend equal to temp equal to directly friend equal to temp means friend is here, free of temp. Easily delete the temp node. That is called insert the begin elements in the single linked list. Insert begin. Coming to next insert and. Same insert and also here one data is one node is there. Next we are declare the temp. For example, this is the temp, this is the rare. For example, zero zero. For example, stored at 1010 101. This is the any node last is null only. So 20 30 here connected like this. We are inserting the end. Immediately new node temp equal to new node. Immediately one temp is one temporary node is declared. So this is the friend, this is the rare. Here rare link equal to temp. Whenever I call rare link equal to temp, immediately temporary temp address is stored at null point, rare link. So that's why this is the one of the algorithm of the insert the end. Okay, rare equal to link means already I have 3 nodes. Then after we are declare the temporary node. Then after we are connected with the rare link equal to temp. Immediately I called rare link equal to temp. Immediately rare address is stored at temporary address is stored at rare address part. So then after already here rare, here temp. So this is the last node. So he called rare equal to temp. Immediately temp is erased and here stored at rare. Free of temp equal to deleted the temporary node. This is the end of the insert the end. These are the linked list. Insert begin, insert end, insert position. Same like as delete begin, delete end, delete position. Searching, traversing techniques also available in linked list. Thank you.